Yes, sir.
Okay, so we have to begin our class immediately. It's already past time. Okay, firstly, I have to introduce myself. I don't know whether you know me. So let me try to do the official stuff. My name is NC Michael, and I'll be your tutor for physics. And I'm sure every one of us came prepared for the class. And I want to believe everyone here is yeah, these are all exam students, right? Please, I would want responses, please. Everyone should try as much as possible. You just speak and then you unmute yourself, you speak, then you put back your mic and mute so it doesn't cause a background interruption, feedbacks like that. Okay, so let's get the class started. We are looking at physics, and the first topic we'll be having for the class today would be motion. We'll be looking at kinematics, and it's something that every one of you already know. But let's see how we can bring more perspective and then go straight to the point, um, majorly on things that matters for your upcoming exam. So let me begin by giving some definition of terms. Actually, how I do my class, I believe everyone here has writing materials such that it helps you to engage. So I dictate stuff, then you put them down. All right. So I like a kind of class, a setting whereby students write down, you jot down things that is being said. Do you understand that? So even though the class is being recorded, you can always go back to the lesson. But I want to believe everyone listening to me right now, you have your pen, your book, and the rest of that. So everything you need, I'm sure they are already. So let's begin by definition, kinematics. That's the first topic we have for today. So I would want somebody to help me. What is kinematics? Who can come to the rescue? What exactly is kinematics? Someone should respond, please. No one is saying anything. Or is it that you just want me to just keep talking, while you just sit back and listen? The class wouldn't
Science
be.
students no dey here, na arts na dey.
Uh-uh. Our science student no go there now, and I dey teach physics. Wait,
Science students
I be
how many
senior
science
man
students? Does it mean that everyone here they are all science, they are all art students?
no, I'm science student.
Okay, wait. I want to know how many science students do we have here?
Only one.
Only you.
Yes.
Okay, that's fine. So it means other persons will join later on. So senior man, you said your name is what again? Or what I'm seeing here is
David.
senior man. Huh?
David, sir.
David. So David, what exactly is kinematics?
Anima.
Yes. Have you heard about kinematics before?
Not really, sir.
Right? No response. You've not heard about motions too. David. Okay. So let's just move on. So the thing is that kinematics is just a branch of mechanics that deals with motion of objects without considering the forces causing the motion. That's one you must know. So in kinematics, we study motion and we don't consider the forces that is causing the motion. So we just try to understand the motion, study the motions of objects. So there are things we try to look at under the study of kinematics. And I'm sure you must have heard of things like displacement, velocity, acceleration, and the likes. I'm sure you must have come across that in class at one point or the other. So that is just what kinematics is all about. Okay, so I said kinematics. So you may just put something down. As I said, I would want us to engage actively by writing down some things. So you might not really expect me to write everything on the screen, even though I can do that. But I prefer dictating the things you don't hear. You call back my attention, so you just take down the note yourself. Does that make sense?
Yes, sir.
All right. So I said kinematics is the branch of mechanics that deals with the motion of objects without considering the forces causing the motion. That's the first thing I want you to know. In kinematics, we don't consider the forces causing the motion. And there are two twin quantities that many a times confuses students in the study of kinematics. One of them is distance and the other is displacement. So because they are being measured in the same, of course, they have the same unit, so oftentimes it's being interchanged. So remember I said in kinematics, we study motion. We study motion. And of course, you know that before, when we talk about motion, it means that something must have moved from one point to another point. Is that not true? That's exactly what motion is. So you can't talk about motion without considering something leaving a point to another point. So if that be the case, it means that distance is involved when we talk about kinematics. And of course, sorry, for something to move, it moves with velocity. All right. So let's say a body at rest, the body moves from one point to another point. Let's assume that I have, this is my horizontal floor. I have this to be my horizontal floor. Oh, my pen is not on yet. So if I consider this to be a horizontal floor, and then I have an object somewhere, here. Let's assume this is a ball. And of course, for this ball to move from this point and then come to another point, it means that that is exactly what one we can say that motion has occurred. All right. So if this ball eventually moves from here, let's say after some time, it comes to this point here. So we can observe two things. Number one is that there is a change of distance between the two objects, between the two bodies. So initially, I don't know why my pen is freezing this evening. So there is actually a change of distance from where it was before to the point where it is now. And of course, if there's a change in distance, it took some time for that object to move from there to the other point. So time is actually a factor. Also, there is a speed with which the object moved. All these things are very, very important because these are the things we'll be looking at in kinematics. You have to consider the displacement, consider the time taken for that motion to occur. We have to consider the speed with which the object move. We have to consider actually the acceleration and the rest of that. Okay, so I said there are two things that confuses students under this subject, kinematics. One of them is distance, the other is displacement. They are very simple, but oftentimes students interpret distance and displacement as distance. But the simple difference between them is just that distance is just the length of a path, traveled by an object. So let's say just like I drew that line, an object moved from one point to another. The total length covered by that object is so-called distance. So we don't consider direction, but in displacement, we consider distance in a specified direction. So displacement and distance are practically the same thing. The only difference is that in displacement, it is just distance in a specified direction. So we can as well define displacement as the shortest distance between, let's say, an initial point and a final position. From the initial position to the final position, the shortest distance. For example, let's also assume if I consider this what's happening to my system? If I consider an object here, oh, this is really, really crazy. What's happening today? What is happening today? What was happening to my way? Okay. Hello, David. Can you hear me? Okay. I want to believe everyone can hear me, right? Okay. I don't know what happened. My system just began to malfunction, and I don't understand the reason behind that. So I have to join back the class with my phone. So let's continue with the class. So I was trying to explain the difference between distance and displacement. And I said for distance, it's just um, the length in space from one point to another point, whereas displacement is just distance in a specified direction. That was what I said. And majorly, what I want us to do in this class is to understand how to solve questions, involving equations of motion. Because under this topic, you might not see questions like, what is this? Or define distance, define displacement. So basically, what they'll be centered on is to ask you questions, whether you really understand how to apply these equations of motion. And every student should have an idea or an understanding of these equations of motion, because when the questions comes out, you have to be the one to decide what to do. And the formulas based on the question will then determine whether you can solve it or not. So basically, we have three equations of motion. So we have the first one. The first equations of motion says that V is equals to U plus AT. We have the second one that says that S is equals to UT plus 1 over 2 AT squared. And then we also have the last one that says that V squared is equals to U squared plus 2 AS. So these are the three equations of motion that we have. And every question of motion centers around these three equations. So, but sometimes you notice that the equations that will be asked wouldn't be on linear motion. It has to do with gravity. Let's say something falling from up to down. So it wouldn't just be like an object moving, like a car, someone running, the rest of that. So it can just be, let's say, an orange fruit drops from the top to the ground. So they want you to calculate the time or the height and the rest of that. So we call such questions motion under gravity. So if the question given to you has to do or has to do with motion under gravity. So for motion under gravity, this same equation can be written down as this, that V equals U plus or minus GT. Then we have also that H, the X here becomes H equals UT plus or minus 1 all over 2 gt squared, where g is acceleration due to gravity. And we have that V squared equals U squared plus or minus 2 gh. Now take note that this V, the V here talks about final velocity, where V is our final velocity. Then the U is our initial velocity. Then our S has to do with distance or displacement. All right. So distance, of course, displacement is also distance, but in a specified direction. And then H has to do with height. That's when when something is falling from up to down, or you want to throw something upward. So that's the height. And of course, our T is time. Also, we have the A, which is our acceleration. And I think the last thing we have there is the G, which is also acceleration, but this time due to gravity.
And of course, you know it's constant. Many a times it's been given as 10 meters per second square. But if it's not given to you, it's a constant, and I'm sure every one of us should be familiar with it. So these are basically the three equations of motion. Now, the problem students have is not that they don't know this equation. Sometimes the problem they have is that they don't even know they want to use and how to use them. And sometimes, let's say, sometimes in WAEC, I've come across questions where the students were being asked to prove this equation. So this equation can actually be proved, and the proof is not difficult, because once you understand how to prove the one, you can actually prove the three, and it's very, very simple to do that. So I wouldn't know whether there will be need, any one of us would want us to prove those equations, or do we just go straight to see how they apply in problem solving? Because I want us to achieve how we can solve the questions when it has to do without a graph, and also how to solve questions of motion when it has to do with sketching a graph. Because sometimes the questions involve sketching, having a graph sketch, and some other time the questions are just using these formulas to work it out. So let's see how to solve the questions, or examples of questions that has to do with stuff like this, using formulas like this, and also we look at how to solve the questions using the graph. So will there be need for us to prove the formulas? I ask again, or do we just go straight to the point? No one is responding. David, I think you're the only science person here, and I don't even know whether you can hear me.
Obawumi is a science student.
Okay, Obawumi and David, I ask, do we prove the equations of motion, or do we just go straight to use them to solve problems?
Prove it, sir.
Okay. Now, the proof is actually very simple. It's not something difficult at all. Now, these are the proofs. Now, the first equation we have is that let's prove V equals U plus AT. I want us to prove this right now. Now, recall, the first thing to do is that you have to recall some of the basic things you already know about motion. Now, what is that? What do I want you to recall? Recall the equation for acceleration. Remember, acceleration is just the change of velocity with respect to time. So recall that A, which is acceleration, is equal to change in velocity, which is our V minus U. Remember, I said that V and U means final and initial velocity respectively. So recall that A equals V minus U divided by the time taken. Of course, if I cross multiply from here, I'll be having that my V minus U is equal to AT. So if I move minus U to the right-hand side, I'll be having that V becomes U plus AT. And that is how they got that first equation there. So sometimes it occurs once in a while, once in a blue moon, you'll be asked to generate or prove the three equations of motion. They'll just ask you to prove it out, to work it out. It's something that occurs once in a while in Y and NECO exams, as well as GC. Now, having proved this, the second equation says that S, this is the first one. This second one says that S equals to UT plus 1 all over 2 AT squared. This is the second one. Now, how do I prove this equation? Also very simple. Now, recall also that speed, your speed, which is S, remember, not speed, please. Your distance, which is S, is actually given by the average speed multiplied by the time taken. This is a formula to find distance. So your distance is given by average speed multiplied by the time. And from what we have here, you already know, or before then, how do we find average speed? When we say average speed, when you say average, how do you find the average of a thing? You sum up the total stuff and divide by how many they are. Is that not true? So average speed here would mean that I will sum my final velocity plus my initial velocity. Of course, I have two parameters here. I'm going to divide by 2. So this can make up the formula for my distance. So the distance S equals the sum of V plus U, which is the final and initial velocity respectively, divide by 2, then multiply by time. So this thing and this thing are actually the same thing. I just substituted the value of V bar, which is my average speed. So, but from what I have here, I already know the equation for V. I already proved that V is equals to U plus AT. So I can make my substitution here. And if I make that substitution, I'll be having that S becomes, instead of having V plus U divided by 2, I'm going to be having that V is U plus AT. That's my V from the first equation. U plus AT, then plus U divided by 2, then everything here multiplied by T. Look at it here. All I did was simply to change this V, change the V, and I put U plus AT, then plus this other U here divided by 2, then everything multiplied by T. And then I can see that U appeared twice, so U plus U is going to give me 2U plus AT divided by 2, then everything there multiplied by the time taken. You see that? So I can split this fraction for the two parameters, or for the numerators. I can split the denominator for the two numerators there. So I'll be having that this is 2U over 2, then plus AT over 2. Everything there is multiplying by T. Then I have, remember, they are all equal to S, which is my distance. All right. So you can see that the 2 can cancel out 2 here. If I use this T and open up the bracket, I'll be having UT. That's what I have here. Then plus, if I factor out this denominator here, I'll be having 1 all over 2. Then I have my AT squared. So that is how that second equation was being obtained. So you see that this is the second equation of motion. Now, the third equation of motion says that V squared is equals to U squared plus 2AS. So how do I prove this also? Still very simple. All I need to do is to square both sides in the first equation. Remember, let me put this in a box. This is my first equation. This is my second equation rather. This is my first equation. I already put that in a box. And then the third equation is what I want to prove now. Now, remember from this first equation, this one here, that V is already U plus AT. So I can choose to square both sides in the first equation. So if I say square both sides, this BS means both sides in the first equation. So let me call that equation 1. So it means that I'll be having, if I square both sides, it means that V squared is going to be equal to U plus AT all squared. And then from your knowledge of mathematics, you should know that this bracket here is going to be expanded. So this will give us U plus AT multiplying U plus AT. Then if I expand further, I'll be having that this will give me U squared, then plus UAT plus UAT, then plus A. Now, let me add up the UAT. So I'll be having 2 UAT. No need to make repetitions, so it doesn't look long. So I have U squared plus 2U AT, then plus A squared T squared. This is what I have here. And of course, from here, I can see that if I put down, remember, I'm trying to prove that V squared equals U squared plus 2AS. So I already have my U squared here. Now, if I factor out 2A from this whole thing here, this whole expression here, if I factor out 2A, I'm going to be having that 2A left in bracket, I have UT. Then plus, because there's no 2 here, let me add up my half. I have half AT squared. That's what I have from here. And of course, you can see that half AT squared is simply this UT plus half AT squared is exactly the second equation, which is my S. So UT plus half AT squared is my S. So I can make that substitution for this equation here. So I have that V squared becomes U squared plus 2AS. And this is how the third equation of motion was also being generated. Remember, I told you, once the equation has to do with gravity, the same equation, nothing changes. The only thing is that these equations, the A is being replaced as G, then the S is being replaced as H, just like we saw in the first slide. So here, the A is being replaced with G, the S is being replaced with H, and just like that. Then the plus and minus will be based on the direction of the motion. If the object is falling, is going from up to down, then I'm going to use the positive sign. But if the object is going from down to up, like I'm throwing something upward, like a boy throws a ball upward, so that object is moving against the direction of gravity, so it's going to be, I'll be using my negative sign here. But if the object is falling from up to down, let's say a ball falls from the top of a tower, or maybe let's say a fruit falls from each tree downward, so I'll be using positive sign. So that is the reason for the plus or minus. It doesn't mean that you use two of them while solving problems. Okay, so far, I don't know if there's any question before we proceed.
No, sir.
Okay. So basically, that is that for equations of motion. Now, let's now see how we can apply them in solving problem, because these equations are important, but their importance actually boils down to using them to solve problems. Now, look at this first question I want us to solve, and I want you to take it down, because my system, everything I have stored up in the system, so I have to dictate the things I have right here. So just take down this question. Are you ready?
Yes, sir.
There's only one person that is responding. Is the only one science student that I have here? David, I thought I heard someone said, is he Bao
Winner.
that
How will maybe now?
the person is no longer in class?
She's in class.
In class.
That's what I'm saying. But she's not active. She's not in class. Okay. But nonetheless, so let's move on. So take down this question, just a very simple one. I can let's say a car moves with constant acceleration.
Yes, sir.
Is that the bar me? Okay. So the question says that a car moves with a constant acceleration. A car moves with a constant acceleration of 3 meters per second square. A car moves with a constant acceleration Can you see the question on the screen, right?
Yes, sir.
So a car, or let's say a train, moves with a constant acceleration of 3 meters per second square, and they want us to find the displacement within 6 seconds, given the initial velocity to be 4 meters per second. So the first thing I always advise students to do is, anytime questions like this comes up, is that the student must know how to list out their parameters, because sometimes the questions look difficult until the parameters are being listed. You understand that? So if the parameters are being listed, it becomes easier for us to solve these questions. Now we have solution. The question says that a train moves with a constant acceleration. So we have acceleration as 3 meters per second square. We equally have the initial velocity, which is u, as 4 meters per second. And they ask us to find the displacement, s. We are looking for displacement within time, 6 seconds. So how do we find the displacement? I have to record the whole equations of motion. Now, the equations of motion, the first one is that v equals u plus at. Then I have that the other one says that s equals ut plus 1 all over 2 at squared. And clearly, I can use this equation to solve the problem. So this second equation actually works. You see that? So using the second equation, because all the parameters I have are being listed in that particular equation. So I can use the equation that S is ut plus 1 all over 2 at squared. So what's my u? 4. multiply by the time taken, which is 6. So 4 times 6 plus 1 all over 2 times the acceleration 3, then multiply by the square of the time. So 6 times 4 is going to give us 24. And 24, 6 square is 36. And if I divide 36 by 2, this will give me 3 times 18. So what I did actually was to use this 2 and divide 6 square. 6 square is 36. And 36 divided by 2 is going to give me 18. So if I multiply 3 times 18, so I have 24. What would 3 times 18 give to us? What's 3 times 18?
3 times 18. 54.
So that's 54. So if I add up 54 plus 24, what would that give to us?
78.
So the answer to that question is going to be 78 meters. So very important, you must always include your unit anytime you solve a problem. So we actually found that our S, which is the displacement, is that will be 78 meters.
Meters.
So this actually how the questions looks like, stuff like this. Sometimes this one looks very direct. Okay, there are some of them that you have to do find this, then find that, and stuff like that before you can actually solve the question. But whichever way the question comes, it's not something difficult. You can always do it. All right, so look at, I have a second question here.
Okay, sir.
This one, I want you to take it down. It's actually a wire question. I'm trying to see how to move it from my system, but I don't know why the system is just lagging. It started this night. Like it's just lagging. I can't even understand. Nothing is working out. Okay. Now, this other question says that a body is thrown vertically upwards from the top of a tower. A body is thrown vertically upward from the top of a tower. A body is thrown vertically upward from the top of a tower, 40-meter high. Do I need to write it down or you're writing it already?
I'm writing it.
Okay. So a body is thrown vertically upward from the top of a tower, 40-meter high, with a velocity of 10 meters per second. So notice they gave us the height of the tower. So let me call it H subscript T, which means height of tower. They told us that the height of the tower is 40 meters. So the tower is 40 meters high. And they said that the body was thrown with a velocity of 10 meters per second. So the initial velocity U is actually 10 meters per second. And the question says, calculate the time taken for the body to reach the ground. Calculate the time taken for the body to reach the ground. Or no? So we need to find, so clearly this kind of question is called, is under motion, under gravity. So a body is being thrown upward. Now it's forced to the ground. They want us to find how long it will take that body to fall to the ground. But notice that the body wasn't thrown from the ground. It was thrown from a tower, and they gave us the height of the tower. So let's assume this to be our tower. Let this my ground level. And then I have something that looks like a tower, even though I'm trying to so let's assume that this is a tower, and then the body was being thrown from here vertically upward. So the body traveled all the way up. And they said that the velocity with which the body was being thrown is 10 meters per second. So U is 10 meters per second. And the height of this tower, they said, is 40 meters. So they want us to find what time will it take for this body to travel from here to this maximum height and then falls back to the ground again? So the body has to travel from the top of the tower to a certain height, which is called maximum height, and then the body will fall back to the ground again. You see that? So this body has, we need to find the time it will take to move from this top of the tower to the maximum height. Then I will also find the time it will take to move from the maximum height back to the ground. Then I will add up the two times. That's how it is. So if I have to calculate the two, if I calculate this T1, then calculate the T2, then everything is going to give me my T, which is the time taken for the object to hit the ground. Now, take note of this. At maximum height, anytime an object is being thrown up, at maximum heights, our final velocity V is 0. Now, notice that the object begins to, as you throw the object upward, the velocity with which it was being thrown begins to slow down. So it slows down to a point where the velocity becomes 0. Then the object begins to fall back to the ground again. So it means that at the point where that object begins to fall back to the ground, there's actually a momentary stop. Even though you don't see that, you might not notice that with your side. The same way, it's not possible for you to be running forward and then run backward without stopping. It's not possible. A car can be moving to and fro, moving forward and then moving backward without matching brake. It's not possible. That is the same way also. This body cannot go up and down without stopping. Do you understand that? So at that point, which is the maximum height, where the object gets to and then begins to fall back to the ground, our final velocity there is 0, and that's V is 0. And this V is taken to be 0 only when the object is thrown upward. Do you understand that? The object is thrown upward, it always has initial velocity. Then when an object is falling from a height, so if the object is going down, an object is going down from a certain height, the U, the initial velocity U is going to be 0. Take note, if the object is falling down from a certain height, that height from where the object is falling from, the velocity at that point is equal to 0. I said two things. The first one is if the object is going upward, the final velocity there before it begins to fall is 0 meters per second. Also, when the object is falling down, the height from where it's falling from, the velocity at that point is equally 0 meters per second. So understand this, because this will help us navigate problems on motion. These are little things that student makes, and by so doing, everything becomes complicated. Now, let's see how to solve, having explained these two things. Now, let's see how to solve this problem. First of all, I want us to find the time it will take to move from here to this point. And we can do that using the equations of motion we know.
Okay.
Let's find the time it will take the object to move from the maximum height, to move from the top of the tower to the maximum height. Recall, look at the parameters they gave to us. They told us that A is 3 meters. No, this is not the equation. They gave us that the height of the tower is 40 meters. I don't need that to find the time. I only need these two. I only need this here, the time. I only need the velocity, with which the object was being thrown. So, which is 10 meters per second. Remember, I told you at maximum height that V is 0. All right. So at maximum heights, our final velocity V is equal to 0. For me to find the time it takes for the object to get to the maximum height, which is the first thing I need to calculate, I can use this equation that V is equals to U plus AT. Since I know the U and the A, let me change that. Since it's motion under gravity, that's U plus or minus GT. You see that? So V is equals to U plus or minus GT. And remember, I told you that if the object is moving upward, that's against the direction of gravity, we are going to be using the negative sign. If the object is falling downward, then we will be using the positive sign. So since the object is being thrown upward, our equation becomes that V equals U minus GT. So, and the U was given to me as 10 meters per second. And at maximum height, our V is 0. So 0 is equals to 10 minus G is a constant. It's not given in the question, but you have to know that G is always 10 meters per second, unless it's 10 meters per second square, unless it's given otherwise, like 9.8 and the likes. But if it's not given, always use 10 meters per second square. So this is 10t. So if I bring this 10t to my left-hand side here, the minus 10t becomes positive. So I have 10t is equals to 10. Of course, if I divide both sides by 10, which is what I want to do here, divide both sides by 10, 10 cancel out 10 here, my t becomes just 1 second. Meaning that for this object here, it took 1 second for the object to get to the maximum height. Imagine you standing on top of a building, then you threw something upward. And then we just calculated that from the top of that building to the point where the object gets to and begins to fall, we calculated that it took just 1 minute, 1 second for the object to get to that maximum height. That's what we found here. Now, for us to find the time it will take for this object to fall down, I need to understand the total distance from this ground to the maximum height. I need to find that. But they already gave me that the height of the tower from the ground to the top of the tower is 40 meters. So let me find the distance from here, from the top of the tower to the maximum height. I need to calculate that also. The distance from this top of the tower to the maximum height. Let me call that small letter d. How do I find my small letter d? Which is the distance from the top of the tower to the maximum height. So I have to also consider the equations of motion. I know. Remember, this equation must always be in your mind. V equals U plus minus GT. Then also we have that H is UT plus minus 1 all over 2 GT square. And then I have that V square becomes U square plus or minus 2GH. That's what I have. Now, for me to find the height from the top of the tower to the maximum, the distance from the top of the tower to the maximum height, which is what I need first before I can find the total height traveled by this object, I need to know what formula to use. I already have calculated my time. Now I know what the time taken to move to the maximum height is, and I know the initial velocity. So I can use this equation. I can use any of these. Any of these equations can actually help me to find the height. If I choose to use this one, I'm going to get the height. If I want to use this one, I'm going to get the height. Now, the idea is just for you to know what to do and which is which. Now, let me use this equation here to find the height. If I use the second one, that H equals UT, let me consider the objects from the top to the bottom, like from the top of this height, from this maximum height. I can consider the object in two ways, depending on what I want to do. If I consider this object moving like this, it means that my U is 0, then my V is going to be what? My U is 10, but my V is 0. But if I consider the object moving downward, that is from the maximum height to the top of this tower, it means that my U is going to be 0, then I'm going to find the V. Do you understand? Then the V is going to be equal to what I have here. So if I have, if I consider the U, H equals UT plus GT square, as the object begins to fall to the ground, it means that the velocity here is going to be 0. So if the velocity is 0, I'll be having that my H becomes 0 times T, everything there becomes 0, plus G is 10. And then, of course, I have 10T squared. Wait, let me observe this again. I think there's a mix-up or something. Let me not do anything wrongly. Okay. I want to be sure of something. Nothing has actually gone wrong, just for more clarity's sake, so we don't complicate issues. Remember, we just calculated the time for the object to get to the maximum height, which is from the top of this tower to the maximum height. And now, what I want to find now is I want to find the distance from this top of the tower to the maximum height. So I can achieve that since I know my initial velocity and I equally know the final velocity, because at maximum height, my v is 0. So let me use this equation that involves those two parameters. This one, the third equation that says that I'm going to be using v square equals u square plus minus 2as. I'm going to be using this, 2gh, since it's motion under gravity. V square equals u square plus minus 2gh. And I remember we said at maximum height, v is 0. So if I consider this to be 0, and then my u square, what's my u? From the question, what's my u? Let me know if you're following. No one is saying anything. What's my u from the question?
10 meters per second.
10 meters per second. 10 square. Now the object is moving upward. Of course, this is going to be minus 2 times 10, then h. So this is, if I bring this minus, this is going to give me 100 minus 2 times 10 is 20, and that's 20h. If I bring this 20h to the other side, minus 20h to this left-hand side becomes, remember here is 0. So this means that 0 minus 20h, this minus 20h comes to this point, becomes positive 20h. So I have 20h equals 100. Now, of course, if I divide both sides by 20, I'm going to be having that h equals 10 over 2 will give me 5 meters. Now, the first equation I wanted to use, which is this one. Remember this second equation, which was the one I intended using before, didn't capture the initial and final velocity. It only has the initial velocity. So I needed to use this second one, which is this, that has to do with both the initial and final velocity, because I need two of them to work this out. So I've been able to find the height, this height, 5 meters. And what is 5 meters? The 5 meters is the height from the top of the tower, to the maximum, to this maximum point here. So the distance from the top of the tower to the maximum point is 5 meters. So if the height from the ground to the top of the tower is 40 meters, and then the distance from the top of the tower to the maximum height is 5 meters, it means that the total height traveled by this object, my total height, h, let me call it h total, is going to be equals to 40 plus 5. So 40 plus 5, and that will give me 45 meters. So 45 meters is the total height from this point here to this point here. So I added this 40, which is the height here, 40, and I added 5 here, which is the height from the top to the maximum height, and everything here gives us equal to 45 meters. That's what I did. So now I've known what the total height is. I can now know the time it would take for the object to fall from the maximum height to the ground. Let me find the time it would take for the object to fall from the maximum height down to the ground. And I'm going to achieve that using the second equation of motion. So, to find the time, from the top of the tower, to the ground, I can achieve that using that h equals ut. Now the object is falling down now. Is in line with direction of motion of gravity, in line with the direction of gravity, which is ut plus 1 all over 2 gt squared. And our age is 45. 45 is equals to, when the object is falling down from a height, our u is 0. So everything here becomes 0. 0 plus 1 all over 2 multiply my g, which is 10. Then I have t squared. Then I have 45 will give me 2 divide 10, 0 plus this 2 divide 10 is going to give me 5. So I have 5t squared. Of course, adding 0 doesn't change anything. If I divide both sides by 5, I have that my t squared is equal to 45 over 5, and that will give us 5 times 9 is 45. So this will give us 9. For me to get t, I need to take the square root of both sides. So my t become the square root of 9. And square root of 9, of course, what's square root of 9? That's 3, right? Yes. So our time from the top of from the maximum height to the ground will give us 3 seconds. Please always add your units. 3 seconds. That is the time it will take for the object to fall from the top of the build, from the maximum height down to the ground. But the question says we should find the time. The question says we should find the time it will take for this object to travel from the top of the tower to the maximum height, and then from the maximum height back to the ground. Remember, the question says find the time it will take for the object to hit the ground. And this object, for it to hit the ground, it has to go up. Then from up, which is it gets to the maximum height, then falls down to the ground again. And we already found the time to get to the maximum height as 1 second. And we found the time to move from the maximum height down to the ground as 3 seconds. So therefore, our total time, which is the time taken for the objects, so let me call this one T2. The first one we found, let's call it T1. So this is my T1, and this other one is T2. So my T is going to be the summation of T1 plus T2, which is actually 1 plus 3. And that will give us total of 4 seconds. So actually it takes 4 seconds, or it will take 4 seconds for that object to fall from the top of the tower, being thrown up with that speed back to the ground again. And this is the solution to that question. Any question?
No, sir.
Okay. Now let's look at another thing also. One more question. There are other theories I want us to touch, but I want to see if I can just hit some of these calculations so that at the end I will just say little things then before we bring the class to a close. Now, another kind of question that is also common on this topic is the one that has to do with sketching graph. There are questions that has to do with you need to sketch a graph. All right. So if you sketch the graph, then that helps us. The graph you sketch determines, if you sketch the graph properly, then it means you are likely to get the question. But if your graph is wrong, it's obvious your question is going to be wrong. And I want us to see a question like that. And I have a question here also. Past question, WAEC 2018. Past question, WAEC 2018. The question, I'll just dictate the question. It doesn't want to be copied out, because I'm actually picking the question from WAEC direct website. Okay, now this is the question here. So take it down. It said a car starts from rest and accelerates uniformly. A car starts from rest and accelerates uniformly. A car starts from rest and accelerates uniformly. For 20 seconds to attain a speed of 25 meters per second. Accelerate uniformly for 20 seconds to attain a speed of 25 meters per second. So there's a full stop there. Now, the next line of the question says it maintains this speed. It maintains this speed for 30 seconds. It maintains this speed for 30 seconds. It maintains this speed for 30 seconds before decelerating uniformly to rest. Before decelerating uniformly to rest. Before decelerating uniformly. Please, who is that? You can just turn off your mute yourself, please. Before decelerating uniformly to rest. Please mute. Okay, let me try to do it from here. Before decelerating uniformly to rest. Now they said that the total time for the journey is 60 seconds. So the total time for the journey is actually 60 seconds. Now the question says we should sketch the VT graph for the motion. So that's the first question. Sketch the VT graph for the motion. So I have my first question to be sketch the VT graph for the motion. VT means velocity time graph. Now the next thing says we should find the total distance traveled by the car, and we should equally find the deceleration of the car. So we should find the total distance traveled by the car, and we should also find the deceleration of the car. So did you get the question?
Yes, sir.
Okay. So now, let's assume, can you solve a problem like this? Let me even ask. Let me begin by that. How would you solve this kind of problem?
I don't really know.
Okay. Okay. Now, look at this question. It's slightly different from it's different from the one we just did. We've solved two questions now, and one of them has to do with just normal linear motion. The other one has to do with motion under gravity. And now we are looking at as it has to do with a graph. Still uniformly accelerated motion, but in this case, we now have a form of the question involving a graph sketch. So we're going to work it out. It said a car starts from rest. Now, you need to understand what is a VT graph. A VT graph is just a graph that captures the motion of an object. Normally, we have two graphs, but that's the DT graph, the distance time graph, and the velocity time graph. So the VT there means velocity time graph. We usually have the velocity on the vertical axis, then we have the time on the horizontal axis. So that's what the VT graph is all about. And it's very simple. And many a times you will always see questions. Anytime WAEC wants to ask you question on graphing, or involved in under this topic motion, you will always see velocity time graph, because velocity time graph gives us more information about the motion of an object, much more than just a normal DT graph. That's very, very simple. Now, this one is equally simple. Now, this is how to do it. Now, remember in a VT graph, I said we sketch the vertical axis. Let me try to see if I can add something that looks like a graph. Let's hold on. Let me try to use a table as my graph. Okay. Okay. This is my graph. Let me assume this to be my graph. Now, I'm going to draw the vertical axis, which is the colon, the that's the path for the velocity. Remember I said that this is called a VT graph. For a VT graph, we'll sketch something like this. I'm trying so hard. Wait. Just hold on for the next like 5 seconds. Let me get my board.
Okay, sir.
Okay. Just something like this. So the vertical axis, that's the column where I put in my velocities. My velocity, that's my V. Of course, the V should be labeled in meters per second. Meters per second. And then the time is there in second. Now, the question says, the next thing now would be for us to represent the information on this graph, exactly how it is on the question. Okay. Hey, what's going on? This whole thing isn't working how the way I want it. Okay, now look at the question here. It said a car starts from rest and accelerated uniformly for 20 seconds to attain a speed of 25 meters per second. So remember they said the car started from rest. Starting from rest means that this car is going to start moving from point 0. So this is my rest point. And this car started moving. Remember they said the car started from rest and accelerated uniformly and attained a velocity or a speed of 25 meters per second. So this car moves like this. This should be a straight line. It travels all the way up, and then they said it attained a velocity of 25 meters. So there is 25. That's the first aspect of the question. And then they now said it maintains this speed for 30 seconds. Meanwhile, the time it took to hit 25 meters per second, the question said is 20 seconds. So I'm going to label under this point, I'll label 20 seconds here, which is the time it takes for the car to attain 25 meters per second, which is our velocity. They now said it maintains this speed for the next 30 seconds. So this car is going to move straight Then for the 30 seconds, so from here, if I trace down this to my graph here, somewhere down here, 30 seconds plus 20, that's going to give me 50 seconds. Remember, they said the car started from rest and then it accelerated for 20 seconds, attained a speed of for 25 meters per second, and then it maintains the speed for 30 seconds. So I'm going to add the 30 to this first time here, 20, which is I'll get 50. So that's the second time here, 50 meters. And then the last aspect of the equation says, and uniformly, okay, maintain the speed for 30 seconds before decelerating uniformly to rest. So the moment the car maintained the speed for the next 30 seconds, the next thing that happened to the car is that the car began to slow down. Please, this is not a curve, it's actually a straight line. So the car slowed down. And they told us that the car slowed down within the next, okay, they didn't give us the time. But they said that the total time for the journey is 60 seconds. So I'm going to have 60 seconds here, which means that the car actually slowed down in the next 10 seconds. That's how we got the total time of the journey to be 50 seconds. So the total time of the journey is 60 seconds, which is also as good as saying that the car slowed down within the next 10 seconds. So here is 60. Now, this is actually the VT graph. Nothing difficult. What I drew here is how the VT graph should look like. So this is how the sketch should look like. This is the first interval where I have my 10 seconds. The car travel for the first 10 seconds. And this is the second interval, which is the next 30 seconds. And then the car now came to rest. From that point, it slows down all the way. Just tilt it a little. Okay, let's leave it this way. Okay, so this is actually how the VT graph should look like. Remember what I have here. Let me write my 60 second more better. The 60 second. Now, the question now says that we should sketch the VT graph, and I've sketched the VT graph. This is actually what the VT graph looks like. Nothing more than just this. It's just a graph that shows us the motion of an object, taking credence with of the velocity and the time. So remember, this vertical axis is velocity, and the horizontal is our time. So what I have here is actually time. So this is time in second. All right. So the next question says we should find the total distance. Now, how do I find the total distance? In a VT graph, the total distance or every segment of this graph has something they do. Now, assuming the question says you should find the distance for the first segment, that is, find the distance after 25 seconds. I'm going to be considering after 20 seconds, which is the time taken for the object or the car to hit 25 meters per second velocity. So I have to consider the area of this shape here. Assuming that was the question, that I should find the time after 20 seconds. I'm going to find the area of this shape because the area of the shape that is formed on this graph, just like you can see here, I have a triangle for the first quadrant, for the first segment. The second segment, I have a rectangle. So this is a rectangle. And then the third segment, I equally have another triangle. You see that? So this triangle, rectangle, and triangle, the area of the total shape would give me the area covered, the distance covered by this object. Now, I can choose to do them one by one. If I find the area of the triangle, I'll write it down for the first segment, this segment 1, then segment 2, and then segment 3. I can equally choose to find them all at once because if I consider the shape as one shape, of course it is. If I consider the shape as one, I can see that that shape looks like a trapezium. So it means that I can actually use the area of a trapezium to find the total area that is being covered by this car. Because what I have here, this entire shape here, this is what a trapezium looks like. We have a trapezium that can be drawn having one slant side and then a straight edge like this. We also have the one that can be drawn having two slant edge like this. Whichever way, whether if the edges are slant, we don't care to know what is two slant. Whether the edges are slant or not, the formula is the same. That's the point I'm trying to make. All I need to consider is the height of the trapezium, which is the straight part. If I consider the height, then I consider this distance here, consider this distance here. That's basically all I need to find the area of a trapezium. Now take note of this. Note that the area of a trapezium, of course, for a triangle, area of triangle is giving us 1 all over 2 base times height. The area of a rectangle, so this is, let me call this T, then this is rectangle A sub R. Of course, it is actually base times height. Then the area for a trapezium, let me call it T sub R, ATR. The area is actually 1 all over 2 bracket A plus B close bracket H. So this is also the area of this trapezium. So it's either I use this, I find the area of the triangle for the first segment, which is this. After finding the area of triangle, anything I get, I write it down. Then find the area of this rectangle. Anything I get, I write it down. Then also find the area of this triangle. At the end, I sum everything together. That will still give me the same result as to when I'm adding using the formula for the area of the trapezium, which is this one. In fact, we'll try the two and see whether it yields the same result. Let's be sure of what we are saying. All right, so let's consider this. Now the question is, where is my A? Where is my B? In this my formula, I said that the area of a trapezium A is actually 1 all over 2 brackets A plus B, then H. This is what I said. Now the question is, where is my A? Where is my B? This is actually my A. Here is my A. The distance from this point to this point is my A. Then the distance from this point, that's the base, to this point is my B. And then the distance, that's the height, from the maximum point here down to the ground is actually my height. And clearly, you can see that my A is the difference between 50 and 20. So if I calculate 50 minus 20, that's going to give me my A. So I can say that A is equals to 50 minus 20, which is the time, and that will give me 30 seconds. All right. So for the B is from 60 to 0. So from the starting point is 0. The ending point of that base there, you can see that the time there is 60 seconds. So clearly, my B is 60 minus 0. Of course, that is 60 seconds. And then the height, H, will be the distance from the base to the 25 meters per second, which is the velocity. And of course, 25 minus 0 is equally going to give me 25. So my base there is 25. So the next thing would be to put all those values into the formula. If A is 1 all over 2 bracket A plus B bracket H, it means that the distance, total distance traveled, is going to be 1 all over 2 multiplying the A. We found that A is 30. 30 plus 60, then multiply by 25. So this will give me 1 all over 2. 30 plus 60 is going to give me 90, and 90, I have 25. So 2 divide 90, that will give me 45. And 45 times 25, that's what I'll be having. So what is 45 times 25? What is 45 plus 25?
70.
70. So 45 plus 25 is actually 7. Did you say 70? I said times 45 times 35.
Okay. One, 1, 2, 5. 1125.
1125. So it means that the total distance traveled by that car is 1125 meters. So you saw that I use the area of a trapezium to compute the distance traveled by the car. And I remember I told you, look at this, it's very simple. Assuming the question says we should find the acceleration, the slope of this graph, which is this bend or this line that is looking slant, this line here, this distance here, the slope of this graph will give us the acceleration of this object. Meanwhile, the total area bounded by the entire line will give us the total area of the shape bounded by this entire line is going to give us the distance. So if the shape is a triangle, then it means that the distance is going to be the area of that triangle. So assuming the question says find the distance for the first 20 seconds, you can see from the diagram, the first 20 seconds will give us clearly a triangle. So triangle, I'm going to use half base times height, and I will get the area. And that area becomes the distance after 20 seconds. If they say you should find the distance for the next 30 seconds, the next 30 seconds obviously is a rectangle. So I'm simply going to do the base times the height, and then I'll get the area of this rectangle. And also, if I do that for this is my first segment, second segment, third segment. If I do them appropriately, and then I add everything together, I will still get the total distance, which is the same as 1125 meters. So do you have any question?
No, sir.
Are you sure?
Yes, sir.
Who is speaking? I saw somebody say something else.
It's me, David.
Okay, I thought I'm hearing some other voices.
No, sir.
Okay, that's fine. So basically, this is just how. So the thing I want you to do is just for you to go practice some other questions that has to do with this quick calculations under motions like this. So it's not really something quite difficult. It's just that many a times students misinterpret the questions and then it makes the whole thing looks hard. Do you understand? Remember, I started this class by defining what kinematics is. So I said it's just a branch of mechanics that deals with the motion of objects without considering the force causing the motion. That is what kinematics is. Nothing more, nothing less. And I said I try to also differentiate between distance and displacement. And I said that distance is just the total length of a path traveled by an object. Also, I said that displacement is just distance in a specified direction, or better still, the shortest distance between the initial and final position of an object, but in a specified direction. Very important. So being a specified direction entails that displacement is a vector quantity, and then distance is not a vector quantity. So just in case you're being asked to find the total, what is the difference between distance and displacement? So one of them is that distance is just the total length of a path traveled by an object. Displacement is the shortest distance between the initial and final position of an object in a specified direction. So distance is a scalar quantity, displacement actually is a vector quantity. So what that means is, what I'm trying to say is that, let me give a very simple illustration for you to understand the difference. Now, let's say somebody travels from this point. Let's say somebody is here. If I say a boy travels 5 meters due east, so 5 meters due east, and then walk back 3 meters due west. See this is where the boy started. The boy traveled 5 meters due east. So this is my east direction from my cardinal point. Of course, this is my west. So he walked 5 meters on the east direction and then walk back 3 meters to the west direction. And the question says, find the distance and the displacement of the boy. Now, the distance is simply my D will be 5 plus 3 because the boy has covered a total distance of what? 8 meters. But for the displacement will be the distance from where he started from to where he is now. And this is where the boy is now. This is where he started from. So we don't get to know how he managed to come here. We are only looking at the shortest distance from where he is and where he started from. And clearly, the shortest distance here, you can see that if from here to here is 5, and then he walked back 3 meters, the displacement S is going to be 5 minus 3. and that will give us 2 meters on the west direction. So 2 meters due west. You see that? So that would be the simple, that's how to answer questions like this. So it's not difficult. All right. So that's the second thing we established. And also, what other thing did I say? You need to understand also the difference between speed and velocity, because sometimes speed and velocity is also another thing that students misinterpret. Nothing difficult. Speed is just the magnitude. It has magnitude, no direction. The magnitude of velocity is speed. So velocity and speed are basically the same thing when you consider them from their magnitude perspective. Magnitude, I mean, is just the numerical value. Do you understand? So like the way you say 2 meters per second, 10 meters per second. Do you understand? But velocity has to do with direction. So in speed, the formula for speed is just distance over time, but that of velocity will be displacement over time, since we are looking at the word direction. And of course, you know the unit is in meters per second, meters per second. All right. So the difference is that velocity, of course, is a vector. This speed is just a scalar, no direction attached to it. That's one thing you should know. And then acceleration, I've explained that also. I said is the rate of change of velocity. I explained that when I was trying to derive the equations of motion. So the rate of change of velocity, meaning the final velocity minus the initial velocity divided by the time taken. That gives us the acceleration of the object. And then the acceleration is a vector quantity as well. And then its unit is in meters per second square. Do you understand that? And sometimes you might be asked, what is a uniform motion? Or what is even a uniform? When you say uniform accelerated motion, what does that mean? So uniform motion simply means that there is no change in velocity. Do you understand that? So the velocity is just constant throughout the entire motion. It is just it's just constant. So any motion that has constant velocity, we call that uniform motion. But uniform accelerated motion is that acceleration throughout the entire motion is constant. Do you understand that? So the acceleration does not change. At every instant in time, the acceleration is still the same. At every instant in time, the acceleration is still the same. And that is the difference. So you need to understand how to define little parameters like this. And then I've explained how to use the formulas involving these equations of motion. Equally, I explained how we can derive them and we solve problems using them. And I think that will be all for this class. If you have a question you want us to do, you can just bring it up. Because later on, I will send you some work to do assignments. I'll be sending some assignments for you to study, to use and practice, and then we'll review that before our next class. So do you have a question? Our time is almost up.
No, sir.
But how come it's just only you that joined the class?
We are till now.
You are three. Who are the who and who made you three? I only have one person in my class, and I'm only going to mark one person as attendance. Only one person came for the class. So let me quickly do that and mark you present. Every other person was absent in the class. So just hold on so I can mark your attendance. So what's your name again? Let me mark the attendance.
David.
David. Dave, that's Ayuba David, right?
Yes, sir.
Okay. So you're the only person present in this entire class. Okay. So David, that will be all for now. So I will, just like I said, I will send in your, what is it called, assignment. So you do well to check it out on your dashboard. And when you're done, you quickly upload it back for review. So have a good night
Okay,
rest,
sir.
David. See you in the next
Thank you,
class.
sir.
All right.
Good day, sir.
Yeah, good night.